Welcome back to the podcast. Today we're diving into a fascinating subject that marries technology and engineering, PCB strain gauges. So let's roll up our sleeves and get into the nitty-gritty of this groundbreaking tech. Now you might be wondering, what exactly is a strain gauge? Well, it's quite exciting. Imagine a device that can measure tiny deflections even down to micrometers. Yeah, you heard me right. These sensors are embedded in circuit boards, allowing us to monitor physical changes with incredible precision. Think of it as having your personal set of ears listening intently to the tiniest flexes and bends of a circuit board. But here's where it gets even cooler. These strain gauges typically have a full-scale deflection range of plus or minus 3 centimeters. Seriously, that's a significant range when you consider the tiny movements we're monitoring. It's like trying to measure the sway of a tree in a light breeze. Moving on to the manufacturing side of things, the recommended thickness for the boards is around 0.6 millimeters. But there's flexibility here. Depending on your application, you could go thicker or thinner. Thinner boards will yield a smaller output voltage swing. It's kind of like tuning an instrument. Sometimes you need to adjust the strings to get the right sound. Now let me paint a picture for you. Say you're working on a project that requires measuring stress on a structure, like a bridge or an aircraft wing. This is where the PCB strain gauge shines. The boards are designed to be hand-assembled, so you don't need specialized equipment like a reflow oven. How convenient is that? And here's a little tip for you tech enthusiasts. You can use an integrated microcontroller, like the Seed Studio Xiao RP2040, or even connect it to an external one. What's cool about this setup is that you can skip the external analog to digital converter if you want, making it simpler to get up and running. When it comes to programming, the supplied firmware is pretty neat. It begins by waiting for a serial console to open, then takes 5 seconds to calibrate itself. After that, it measures continuously, great for real-time applications. One important thing to remember if you're aiming for high accuracy is to allow the board to reach a stable operating temperature for at least 5 minutes before you start the calibration. Trust me, a little patience goes a long way in precision measurement. Now, for those of you who might be looking to create custom shapes for your sensing element, there's an accessible tool called drawfootprint.ipnb. It lets you define the width, height, and even curvature of your sensing element. Once you create that design, you can easily convert it into a KiCad footprint. It's like being an artist, but for electronics. Before we wrap up, I'll leave you with a thought. This tech isn't just about numbers and measurements. It's about enabling innovation. Whether in architecture, aerospace, or manufacturing, the implications of using PCB strain gauges are vast and exciting. So next time you think about the engineering behind structures around you, remember the tiny yet powerful strain gauges doing their job silently. Thanks for tuning in today. Keep innovating and creating with curiosity. Until next time, keep measuring the world around you.